Hello everyone. Welcome. Today, we are diving into a fundamental process in any clinical laboratory, how to calibrate a biochemistry analyzer. This is a critical step to ensure the accuracy and reliability of every patient result that comes out of the machine. Think of it as tuning an instrument before a concert. If it's not tuned correctly, all the music will be off. The same principle applies here. So, let's get started with the essential steps for a successful calibration. First, preparation is key. Before you even touch the analyzer, you need to gather your materials. This includes your calibrators and your quality control materials, often called controls. Make sure to check the expiration dates on everything. Using an expired calibrator will lead to a failed or incorrect calibration. It's also important to allow all your reagents, calibrators, and controls to reach room temperature before use, as temperature fluctuations can affect the results. Also, give your analyzer a quick check to ensure it has enough wash solution and that there are no error flags active. The second step is understanding your calibrator. A calibrator is a substance with a very specific, known concentration of an analyte, like glucose or cholesterol. The analyzer will use this known value to create a reference point or a standard curve. This is how it learns what a specific concentration looks like, allowing it to accurately measure unknown concentrations in patient samples. Some calibrators are ready to use, while others are lyophilized, meaning they are in a powder form and need to be carefully reconstituted with a specific diluent. Always follow the manufacturer's instructions precisely for this. Third, you'll run the calibration on the analyzer. You'll navigate through the software, usually to a dedicated calibration menu. From there, you will select the specific test or tests you need to calibrate. You will then load the calibrator onto the instrument, typically in a sample cup placed in the sample rack, just like a patient sample. Once it's loaded, you'll instruct the machine to begin the calibration process. The analyzer will then automatically aspirate the calibrator and perform the measurement. Fourth, you must review the calibration results. After the run is complete, the analyzer's software will tell you if the calibration has passed or failed. It will often display data like a calibration factor or a curve. You need to verify that these values fall within the acceptable ranges defined by the test manufacturer. If a calibration fails, don't panic. The first troubleshooting step is often to simply repeat the process with a fresh vial of calibrator. It could also indicate an issue with the reagent or the instrument itself. Finally, the fifth and most crucial step is verification. After a successful calibration, you must run quality control samples. These controls have known ranges, typically a low, normal, and high level. By running them, you are verifying that the new calibration is accurate across the entire reportable range. If your control values are within their acceptable ranges, your analyzer is officially calibrated, verified, and ready to produce accurate patient results. And that's the basic workflow for calibrating a biochemistry analyzer. It's a process that demands attention to detail but is essential for quality patient care. Thank you so much for watching. If you found this guide helpful and want to see more content for laboratory professionals, please consider liking this video and subscribing to support the channel. It truly helps us create more videos for you. See you in the next one.